Morning, everybody. Today we're going to be looking at a couple of equations with astrophysics, all right? You should have done most of the reading already from your textbook, but I wanted to talk a little bit about the equations just because there's a couple of different ways we use them, and I just want to make sure that you understand exactly what's going on so that maybe at a later time you can explain it, all right? So you should have all the basic terminology, all the planets and comets and galaxies and different types of clusters and things like that at this point. Make sure, and I know I've written this already and I've told you to put in your notes, but just make sure that you understand what each of those are and what the differences are between them and also how they're similar. All right, those are typical questions on an IB exam. You want to make sure that you can answer those. Now, as far as the calculations for this first section, okay, there's three different equations that show up. You can see all three of them in your formula packet. Today I'm going to be talking about two of them, all right? The first one is the parallax equation, okay? Now, parallax, the easiest way to be able to kind of think about how it works is if you hold your finger in front of your face real quick, okay, and then close one eye, okay? Now, when you close one eye, what's going to happen is that this eye, the one that's open, is going to see your finger, right? Now, if you switch eyes real quick, like that, now I'm looking with my other eye. Now it's looking at a slightly different angle, looking at that same finger, even though the finger hasn't moved. But you'll notice that when you switch back and forth between one eye and the other, what you're getting is it looks like the finger is moving back and forth. Okay? Now look at something that's really far away. The back side of the room may or may not quite be far enough. All right? But if you switch, you'll notice that it's not changing quite so much. And if you put your finger back there, you'll notice that your finger is moving a lot more than the background is. Now imagine if that background was much farther away. If you go to the window and look outside of your room and look in the distance and then do that with your finger, what you'll notice is that the background basically doesn't move. The background is so far away that switching from one angle to the other isn't going to make a big deal. However, the object that's closer to you is going to look like it changes significantly from one position to another just because you're looking at it from a different angle. All right? So this is how parallax works. So this is one eye, and this is your other eye, right? So you're looking at this star as compared to several other stars or galaxies that are in the background, okay? So when I look at the star in this way, I get a specific angle with respect to my face, right? When I look at the star this way from the other eye, I get a different angle from a different position, right? Now, these are not the parallax angle. The parallax angle is actually from the center right here. This angle right here is my parallax angle, just like that. Now, if we apply this to the situation of the Earth going around the sun, we're going to use the Earth for both eyes, okay? It's just we're going to look at one, and then half a year later, after the Earth has gone halfway around the sun, we're going to look from the other eye. We're going to look from the Earth on the other side. So this is how it works. You've got the sun in the middle. That's a brilliant sun, I know. Then you've got the Earth, which at one time of the year is here, which is going to look at this star over here, which compared to the background, we're going to be able to measure this angle right here, okay? And then the Earth is going to continue going around the sun, and 6 months later, half a year, right? Because it's got to go halfway around the sun. Half a year later, it's going to be here. And so when it's here, I'm going to look at that same star, and I should be able to get this angle right here. Right? Now, with those angles, I should be able to calculate the sun is the center. So the sun is the center. I should be able to calculate this right here, which is my parallax angle. Okay? So that's the idea, is we're looking from one eye and then looking from the other eye, just at slightly different times, and assuming that the star and the background aren't moving very much, then the reality is the only reason the star looks like it's moving is because of this idea of the parallax, like your eyes switching back and forth. All right? So that's the idea behind parallax. Now, once you have the idea, the equation is quite simple, right? The equation even gives you the units, right? It tells you that the distance will be in parsecs, or needs to be in parsecs, and then it's going to be equal to 1 over the the parallax angle in arcseconds, right? So all you need to do is you need to make sure, generally you're going to have the angle because we're going to be able to measure the angle. That's what we can measure from Earth. So if you have the angle, then you just need to make sure that the angle turns into arcseconds. Now those that aren't familiar with it, if I have 1 degree, a normal degree, you know, your 360 degrees, the old stupid thing that the Babylonians came up with, 1 degree is the same thing as 60 arc minutes. Okay, 60 arc minutes. 1 arc minute is equal to 60 arc seconds. Okay, it's like an hour is 60 minutes and a minute is 60 seconds, right? It's exactly the same. They kind of came up with basically by the same people, same idea. Okay, so same thing. All right. Now, if you want a simpler thing, you can just say that 1 degree equals 3,600 arc seconds. Okay, so with that, you should be able to turn your number of degrees into arc seconds. Once you have arc seconds, then you should be able to put it straight into the formula. Please put it in arc seconds. Once you have that, you should just be able to solve for the distance in parsecs. Okay, now parsecs have been defined in such a way that this works. So you don't have to worry about it. It's going to work as long as you get the actual parallax angle. Make sure that it's this angle right here, not the whole angle. The whole angle is not the parallax angle. The parallax angle is from the center to that point. All right? So hopefully that'll help you as you do some questions with that later on. Okay? One last thing before you go. There is a type of question that's common where it asks about an angle that's been subtended. All right? So this is just going to take an extra 60 seconds, but I want to talk about the angle that's been subtended. All right? Now, when it talks about an angle that's been subtended, basically what it means is we're assuming that we are stationary now. All right? Now, if we're stationary, and let's say that I'm looking at a star that's much bigger than me, when I talk about an angle that's subtended, maybe over the whole diameter of the star, then what that's talking about is from my viewing point here, this is the angle that is subtended. Okay, so basically it's just saying this is the angle that I see when I start at this point and go to that point. All right, so this could happen for a sun, right? Looking at the diameter of the sun or of the star. It could be for a planet. It could be, say, this is Jupiter, and there's the red spot, right? You could have an angle going from the top of the red spot to the bottom of the red spot, like this, right? And then you could measure that angle right there, all right? So this idea of the subtended angle, remember that just means that we're assuming that we are stationary, and then we're going to branch out from there to look at this over that. In this situation, this is not parallax, it's a different situation, though it is very similar in how we can work it. Recognize that this angle is the whole angle. It's not that half that we're looking for when we do a parallax. All right? So hopefully that's enough to get you started and get you through some problems. Please do let me know if you have any issues or questions, and I'll help you out on Teams. All right? See you later.